Okay, so now we are going to look at the different building blocks of the CNN architecture. So for that, we will first import all the tools that are necessary, or all the imports that are necessary. So we import Torch, you import Torch neural network module, that is as NN, a NumPy array, and the matplotlib. Okay. Then next, we are going to define an environment. Just check the PyTorch version, whatever Google Colab is providing, and then we'll define an image. Okay, and let's plot the image. Plot the image. So it has a CUDA version. That means it can work with uh, that means it can work with your GPU unit. Okay, so this is your input image. So it's black. So it's just 6x6 size. It's a very huge pixel image. Okay. So now then we'll define the kernel. So let's define a kernel like this, and this is where it will start learning. Right? So this is my vertical edge kernel data, 3x3 kernel data that I was showing in the example. And PyTorch kernel has a shape. So look at that. So it has kernel equals to torch from NumPy. So this is a NumPy array, right? We have to convert it into torch. So vertical edge data and reshape into 1133. For output channel, input channel, height and width. This is how you PyTorch can take in the kernels, the PyTorch kernels, right? Create the PyTorch kernel. So now look at that. Okay. Now we will do stride and padding. So we'll use a convolutional neural network, stride 1. Okay. And so it's a convolution 2D neural network. So NN is the modules coming from PyTorch. In channel 1, out channel 1, kernel size 3, stride 1, padding 0. Right? And then manually set the layers weight to the predefined kernel, in parameter, kernel, in parameter, no bias. We are not keeping any bias. Feature map, convolution layer valid, input tensor. Okay. So we have defined this layer, and now we'll do stride 1. Okay. And then we want to visualize. So valid padding output, it changed it to the shape is 1144. Same padding output 1164. So this is it is the padding output. So if you keep the padding or not keep the padding, that's basically differs, changes. Okay, how the valid output shrinks the, so we'll print that statement here. So notice how valid padding shrinks the output while the same padding preserves the output. And then we will have the ReLU, and let's just check before and after ReLU. So before ReLU and after ReLU, it just goes to 0. It's all non-linear, so it's 0 and then it increases, right? And that. Before ReLU and after. Hmm. That there was some error before value, and this one goes after value, right? So it's non-linearity introduced in those numbers which are lower than some predefined value. Notice all the negative pixels values. So you can notice that the negative pixel values from before map have been set to 0 in the after map. Okay, and then let's do the pooling layer. So it's taking the maximum pull. So before pulling 1166, max pulling 1133. So we're taking those bunches right together and max pulling. So just take the maximum value. Okay. And finally, flatten it out. Okay. So it's so you have a layer, then output layer flattens it out. So that's the flattened matrix, and then just shows this as a one row matrix, right? And then we use a softmax layer to check the probabilities. Right? So this is the one checking the probability. Okay, and we'll put everything together. Do a simple neural network. So I'll just define that neural network. Let me do that. So you have okay. Simple with convolution neural network, ReLU pooling, convolution neural network 2. So this is one block, two block, then this is classifier, flatten, linear, and ReLU, and flatten, linear, and ReLU. And then forward, so pool 1, pool 2, flatten, ReLU. So convolution neural network, ReLU, pool 1. Then it goes into the second block, convolution neural network 2, ReLU, then pool 2, flatten it out, then also apply a ReLU, then find fully connected layer, and finally it gives you the complete model. Now, yeah, and that's how you make a complete model. So this is your complete model. So convolution, this is how uh, output shape is this, input shape, that getting the information from the touch input. Maxpool 1833 convolution neural network 116. So notice the size increases 33 channel sizes. Okay, value in channel out channel. Right? So one channel is 1, out channel 16, 33 is maximum height and width. Pooling, flattening it out 1 into 16. So 16 is the number of channels. Linear it's 1 into 13. Okay, so flatten and then linear, and then ReLU 113, and then linear layer, put it on a linear 1 to 8, 1 to 10. Okay. So create a linear layer. So we defined a linear layer over here. Input features is 32 and output features is 10. Okay. And yeah, okay. That's all for this notebook. I hope you like it.